Hi everyone, this is your second lesson for Chapter 3, Parallel and Perpendicular Lines. Your notes today should be titled 3.2 and 3.3. With the learning target, I will be able to use angle pair relationships with parallel lines and to prove that lines are parallel. Make sure your notes are titled with the section 3.2 and 3.3 before moving on to the next slide. So last time we talked about different pairs of angles that are formed when we have a transversal and two lines that cross through it. Today specifically, what we're going to be looking at is what happens if we know that those lines are parallel. For example, I can see this red arrow on L and this red arrow on M are indicating that the given lines that cross through the transversal are parallel to one another. What happens is we know certain things about pairs of angles. Specifically for corresponding angles or alternate interior or alternate exterior angles, we would know that those given angles are congruent. Let's take a look at our diagram to be able to prove that. So I'm going to show a pair of my corresponding angles to start. So remember, corresponding angles are on the same side of the transversal line K in the same position. So for example, these two angles would be corresponding. Notice they look congruent. They look as though they are equal in measure. That would be true for each of the four pairs of corresponding angles created when L and M cross the transversal K. Those two angles would be congruent. That same relationship exists for the alternate interior angles. For example, I could look at these two for a pair of alternate interior angles that are on opposite sides of K, but in between the lines L and M. And that same relationship would also be true for alternate exterior angles. For example, here and here. Two angles, again, on opposite sides of the transversal K, but outside of the lines L and M. So a pair of corresponding angles is congruent, or alternate interior, or alternate exterior. Now, this works the opposite way as well. So down below, we can see that in this particular diagram, we do not see those parallel marks on L and M. There are no arrows on L and M. What I do know, however, is that if I were given a pair of angles that were congruent, I could decide the lines were parallel. So say, for example, the problem told me that these two alternate interior angles were congruent. Then my conclusion could be if those angles are congruent, therefore the other way around also works. I will know in conclusion the two lines that are given, L and M, must be parallel. So notice it works both ways. Either we know the lines are parallel, so we know some stuff that the angles are congruent, or the flip-flop. If the angles are congruent, then the lines must be parallel. This congruent relationship is true for these three pairs: corresponding, alternate interior, or alternate exterior. Let's take a look at one other relationship, and that's for same side interior or same side exterior. Notice we have the same setup. If the two given lines are parallel, L and M, we see the red arrows again showing that L and M are parallel. What do we know about the same side interior or same side exterior angles? So for example, let's take a look at a pair of same side interior angles on the same side of K, in between L and M. Those two angles are clearly not congruent, right? This one's obtuse, while this one is acute. Same thing if we were to look at a pair of same side exterior angles on the same side of K, but now outside of L and M, so exterior. Again, not congruent. This one also looks more obtuse, while this one down here looks more acute. These relationships are not, in fact, equal to each other, but instead supplementary, meaning that the angles will add up to 180 degrees. So the purple one plus the other purple, same side interior, would add up to equal 180. Or the two red angles, the same side exterior, would also add up to equal 180 degrees. The same will be true in reverse, meaning that if I knew one of those angle relationships were true, meaning I knew the same side interior or same side exterior angles were supplementary, I could conclude on the back end that the lines are parallel. So for example, if I knew that these two same side interior angles added up to 180, I would know for certain that L and M are parallel. Or looking at a pair of same side exterior, if I knew these same side exterior angles added up to 180, then I could decide L and M must in fact be parallel to one another. So we're going to look at a couple different relationships and examples of how we prove this. But these are your notes for today, that if angles are corresponding, alternate interior or alternate exterior, they must be congruent, equal to one another. If they are same side interior, same side exterior, they are supplementary and add up to 180. Let's take a look at example 1. In example 1, we want to fill in the missing angles and then determine if the lines are parallel. So let's go ahead and start with the first one. If I know this one is 75, I know the vertical angle across from it is also 75 degrees. I know the one next to it is 105, remember, because two angles that are next to each other on a straight line have to add up to 180. And again, the vertical angle across from that is also 105. We can do the same thing down here, 105, the vertical angle across from it is also 105. The one next to it would have to be 75 so that they add up to 180, and then 75 and 75. Our goal here is to decide, are these two lines parallel? Well, if they were parallel, any one of our angle relationships would have to be true. When I can see all the angles here, I'm not looking for any one particular angle relationship. There's lots of different examples. For example, I could look at the alternate interior angles. If the lines were parallel, alternate interior angles should be congruent to one another. They are not, so my answer here would be that these two lines must not be parallel to one another. Let's do example 2, and then I'll give you some time to do 3, 4, 5, and 6 on your own. So in example 2, let's do the same thing. 100, we know the one across from it that's vertical must also be 100. We know the one next to it must be 80, so that they add up to 180 degrees in a straight line, and then 80 must be across from another 80. Same thing down here. 80 has to be across from 80. The one next to 80 must be 100 so that they add up to 180. And then 100 has to be across from another 100. Again, now that you have all 8 angles filled in, you can use any of your different angle pair relationships. So you might not use the one that I'm using to prove it. I'm going to try and use a different one for each example so you can see a bunch of different examples. Let's take a look at maybe the same side interior. So same side of the line inside of the two given lines. We have 100 and we have 80. Well, our same side interior relationship says that the two same side interiors should add up to be supplementary. In this case, because they are equal to 180, we could say that the lines are parallel. Notice we could have used lots of other relationships too. The alternate exterior are congruent, the alternate interior are congruent, corresponding are congruent, same side exterior add to 180. So there's not one correct answer for the angle pair that I'm choosing to use to illustrate my example. Pause the video here and go ahead and fill in the rest of your angle pairs in your notes, and then continue the video when you're ready to check your answers. All right, let's go ahead and check your answers here. For number 3, I saw that the two given angles 40 and 80 added up to 120. I filled in all the rest of the angles here and found that 60 and 70, which are corresponding angles, were not congruent. Therefore, the lines in number 3 were not parallel. For number 4, I filled in all the angles and found that the alternate exterior angles, 165 and 155, were not congruent, so therefore the lines were not parallel. In number 5, I filled in all the missing angles and found that 80 and 80, a pair of same-side interior angles, only added up to 160, not 180 like they're supposed to, so those lines were also not parallel. In the final example, the given angles 30 and 80 both added up to 110. I filled in all of the other missing angles and looked at one particular pair of corresponding angles which were congruent like they're supposed to be. Therefore, those lines are parallel. So these are a couple different examples where you can look and fill in different angle measures and decide, are our angle relationships true? Meaning, are the pairs of angles that are supposed to be congruent, corresponding, alternate interior and alternate exterior, actually equal to each other? Or are the pairs of angles that are supposed to be supplementary, same side interior or same side exterior, do they actually add up to 180 degrees? Let's go ahead and look at example number 2. Draw this picture in your notes for example number 2. Our goal here is to name this angle pair and then write and solve an equation for y. So I'm looking at this angle pair with the given expressions 3y plus 53 and 7y minus 55. These two angles are on alternate sides of my transversal. Notice my transversal is here with my two parallel lines shown by the red arrows. The two given angles are on opposite alternate sides of the transversal, and they are outside of the parallel lines. So therefore, the pair of angles that I am looking at in this problem, example 2, are alternate exterior angles. We know that when lines are parallel, like they are in this picture, alternate exterior angles will be equal to each other. So the equation I'm going to use to solve for y is to set them equal. 3y plus 53 equals 7y minus 55. So I'm going to go ahead and solve that equation for y. I like to keep my y's positive, so the first thing I'm going to do is subtract 3y from both sides. Those will cancel out, and I have 53 equals 7y minus 3y is 4y minus 55. Now that I got my y's together, I can get the numbers together, so I'm going to add 55 to both sides so that the 55 cancels from the right side, and I will have 108 is equal to 4y. So my last step will be to divide on both sides to get rid of 4 and find that y is equal to 27. So because I knew that these particular angles were alternate exterior on opposite sides of the transversal and outside of the parallel lines, I'm able to write an equation based on their relationship that they're congruent or equal, and then solve for y. Make sure you have this picture as well as the work for the equation with the answer for y equals 27, and then move on to example 3. For example 3, the directions say, given that lines M and N are parallel, write and solve an equation for x and then find the value for y. The first thing I'm going to do, since the words in the problem told me that M and N are parallel, but they're not labeled at all, is I'm going to label them with arrows so that I remember the problem told me that those particular lines, M and N, are parallel to each other. Now I'm going to write and solve an equation for x. So if I look at my two x's in this equation, I can see that they are next to each other on a straight line. That's one of our angle pairs from chapter 1. Two angles that are next to each other on a straight line will always add up to a straight angle, 180 degrees. So my equation for x will be that 3x plus 8 plus 8x plus 18 is equal to a total of 180 degrees. To solve this equation for x, I'm going to combine like terms. So 3x and 8x can combine together to make 11x. 8 and 18 can combine together to make 26. And I'll set that equal to 180 degrees. Subtract 26 from both sides, and I'll get 11x equals 154. And my last step to get x alone will be to divide by 11 on both sides so that I just have x. When I do 154 divided by 11, I'll get that x is 14. Now, in order to figure out an equation for y, I need to plug in my x to both sides and figure out what my equation is going to be. So if I were to plug in my x, which is 14, let's take a look and see what I get. Say I plug in x for this particular angle here. So I'm going to do 3 times 14 plus 8 and see what I get. So 3 times 14 is going to give me 42, plus 8 gives me a total of 50. So this particular angle would be 50 degrees. If I plug in my x over here, 8 times x plus 18, let's see what I get. So 8 times 14 gives me 112, plus 18 gives me 130. So I can tell I'm on track and doing this problem correctly because those two angles do add up to 180 degrees. Now I need to write and solve an equation for y. Well, I can tell that y minus 16 is going to be equal to 50 degrees. The way that I know that is because y minus 16 and 50 degrees are alternate interior angles. So I'm going to write and solve that equation. So y minus 16 will equal 50 because those are alternate interior angles. So to solve, I'm going to add 16 to both sides to get y alone is equal to 66. So we were able to write and solve an equation for x and for y as we're solving this problem. Notice the x's, because they were on a straight line together, were equal to each other. Then I needed to plug that in to be able to write and solve an equation for y. And the reason I set y minus 16 is equal to 50 is those were alternate interior angles. Let's look at one final example for this section. In example 4, you're going to want to copy that picture into your notes. And then we're going to follow a variety of different steps. It says to first identify the vertical angles. Vertical angles we learned in chapter 1. No matter what the other relationships are, vertical angles will always be equal or congruent to each other. So I have a pair of vertical angles here. They're the ones that are across from each other in the x. I know that no matter what, those vertical angles have to equal each other. So step 1 of this problem is to set those two vertical angles equal to each other and solve to see what I get. So let's go ahead and do that. Again, I always like to keep my x's positive, so the first thing I'm going to do to solve is subtract 5x from both sides. That'll give me 2x plus 2 equals 12 on the right side. Now that I have my x's together, I'll get my numbers together, subtract 2 from both sides, and I'll get 2x equals 10. Therefore, for the first step of this problem, I'm going to see that x, when I divide both sides by 2, x is equal to 5. Let's go back and show that division just to make sure that we show all of our steps. Divide by 2, and we get x is 5. Now it says plug that value in to determine if the lines are parallel. So let's go ahead and plug in that particular value. Now I could choose to plug it into either one of these and I should get the same answer. I'm going to do both just to show that I really do get the same answer. So let's start here. If I do 7 times 5, that's 35, plus 2, this angle would be 37 degrees. Let's check the other one. 5 times 5 is 25, plus 12 is also 37 degrees. So the final step of this problem says to determine if the given lines are parallel. So are these two lines that cut through the transversal parallel? Well, I can now say yes for two different reasons. I can either say yes because the alternate interior angles are congruent, so 37 and 37 are alternate interior angles. And in fact, in my description down below, that's the reason that I gave, yes, because when we plug in x, we found that the alternate interior angles are equal. They're both 37 degrees. However, an equally correct explanation would have talked about the corresponding angles, which are this 37 still given, and this 37, which are corresponding on the same side of the transversal in the same position. So you can say yes to this last question either because of the green alternate interior angles or the yellow highlighted corresponding angles. Ultimately, what that means is when we plugged in and our angle relationships were true, it means that I could go back and say, okay, because those were equal, 37 and 37, now I know that those two given lines are indeed parallel to each other. This is the end of your 3.2 and 3.3 notes for today.